Next, analysis of variance. ANOVA, ANOVA. Analysis of variance is a statistical test used to analyze the difference between the means of more than two groups. Suppose if there are 5 to 6 groups, you want to analyze the mean, that is the average between the groups. So we can use analysis of variance technique, right? That is, it is used to test the equality of 3 or more population means by comparing the sample variance using F distribution. So we are comparing the means, that is there any difference between the groups? Suppose if there are 5 groups of students, if we are checking the IQs, right? IQs of these 5 groups of students. So first group mean, second group mean, third, fourth, and fifth. We are getting the average mean of these 5 groups and we are comparing. So all are, is there any difference, significant difference between the means? That means in the IQs, or there is no difference. We are checking that one. Just we are comparing using the F distribution, using the variance, right? In the F distribution based on variance. So we are using F distribution. Suppose there is a group of patients who are suffering from fever. They are being given 3 different medicines to cure fever. To understand the effectiveness of each medicine and choose the best among them, the ANOVA test is used. Techniques of analysis of variance. First, there are 3 techniques. First one-way classification or completely randomized design, CRD. Second one, two-way classification or randomized block design, BRBD. Then third one, three-way classification, that is Latin square design, LSD. So assumption involved in ANOVA. The samples are drawn from the normal population. So without this assumption you cannot use ANOVA, right? So samples are drawn from normal population. Samples are drawn independently from the population. All populations have the same variance. So these 3 are very important assumption. Without this assumption you cannot check, you cannot use ANOVA test, right? First one, completely randomized design or one-way classification. In this, all treatments are randomly allocated among all experimental subjects, right? So treatment means, suppose if you are coaching 10 students, though the coaching techniques will be randomly allocated all the students, right? So there is no partiality, just you are applying, all students are getting equal treatment, right? This allows every experimental unit to have an equal chance probability of receiving a treatment. In this design, we would randomly select 60 students and randomly split them into 2 groups with 30 each. One group does not take the practice exam while the other does. So we are having 60 students, right? So out of that we are splitting into 32 groups. All are selected randomly. Just you are taking 30 students without any property or any some special requirement, right? Just we are splitting into 30 into 30 randomly, and one group taking practice exam. They are doing practice exam 1 2 3 practice exam 2 3 4 5 like that. Other set of 30 students, they don't have they don't take any practice exam. They are going to main exam directly, right? The two groups taking the two groups then take the actual exam, that is main exam, and we compare the final result. So randomly assigned students to treatments. So first 30 students, second 30 students, treatment A, no practice, right? So they are having practice exam. So finally analyzing, comparing the final exam results, how they are performing, right? So here null and alternative hypothesis in CRD, how to define, right? Null hypothesis H naught, that is all means are equal. So mean means you know mu, right? Mu1, mu2, all the groups. If you are having R groups, all means are equal. So that is the treatment means all are equal. So alternate hypothesis, this just opposite to this one. All means are not equal, right? So advantage of CRD, it is a simple way, right? There is completely flexibility as the number of replication is not fixed. So you can repeat the course of test, right? So analysis of variance, one-way classification, right? Procedure. First, n total number of items in the given data, and small r is number of treatments, and small c is number of samples in each treatment. Step 1. So define hypothesis, null hypothesis, H naught is equal to mu1, mu2, all are equal means, right? And alternate hypothesis H1, so all means are not equal, right? Step 2, so prepare the following table. So calculation for ANOVA. First class, write the class, then values, number of blocks, then write number of blocks, then given data x11, x12, all are right. Then just do the row totals, first row total, second row total, r1, r2, r3, and sum up all those things, you will get grand total g, summation ri. Then ri square divided by ci. So you know ri, so square ri, then divided by a number of columns, C1, C2, C3, right, etc., etc. So sum of this, you will get summation Ri square by Ci. Then sum of square, that is S dot S, sum of square. So squaring each data, right, x11 square, x12 square plus etc., etc., x1c square. Adding all those things, you will get summation first row xij square. Similarly, second row summation square, sum of square, right? Similarly, all the rows you are finding the sum of squares and add up all those things. So double summation xij square, right? Then you find the CFs. CF means correction factor, that is equal to g square by n, right? Correction factor CF g square by n. S dot S means sum of squares, right? Then find the total sum of square, TSS, sum of squares of all item minus correction factor, right? Step 4, find the sum of square between the samples. So sigma Ri square by Ci minus Cf, right? Then next, find the degrees of freedom, df. First degree V1 is R minus 1, row minus 1, number of rows minus 1, and V2 is equal to number of item minus number of rows, n minus r. Next, find the sum of square within sample, WSS. So total sum of square you know, TSS, minus sum of square between the sample you know, BSS, right? Prepare the ANOVA table. So this is the ANOVA table, source of variation between sample, within sample, sum of square. First BSS, second one WSS, right? Down total sum of square, TSS or SST. Degrees of freedom, so r minus 1, n minus r, then add up n minus 1, that degrees of freedom. Then mean sum of square between sample, MBSS, between square mean, right? BSS by degrees of freedom, r minus 1. Then within sample, that is mean sum of within sample sum of square, right? Within sample sum of square, MWSS, WSS by n minus r, that degrees of freedom. Then variance ratio, F test, FC, right, calculated value, that is what FC, which is equal to MBSS, mean between the sample by mean within the sample, or mean within the sample or mean between the sample. This is according to if which one is higher, when you comparing mean between the sample and mean within the sample. If mean between the sample is greater than mean within the sample, you write mean between the sample in the numerator, and that is highest number in the numerator and smallest number in the denominator, right? Then calculating variance, so calculation, so that is what I told you, right? Which one is the higher? Based on that you have to calculate FC. Next, conclusion. If calculated value is greater than tabulated value is taken from the table, F table, right, based on the degrees of freedom. So 5% level or 1% level. 5% level 0.05, 1% level 0.01. That is level of significance. Level of significance is LOS. For degrees of freedom V1, V2. Then the null hypothesis is rejected. If calculated value is greater than tabulated value, our H0 is rejected, null hypothesis. That means H1 is accepted. Similarly, if calculated value is less than the tabulated value, right, then the null hypothesis is accepted. That means H1 is rejected, alternate hypothesis is rejected. So tabulated value is taken from the F table, statistical table, right? Thanks.